Now, before we begin, I'd like to say a few words. How about that right in? I guess that's why they call it SendHub. Ha ha ha. At first I had a one-man wolf pack, and then my wolf pack, it grew by 3. And today, we have the pleasure of listening to my wolf pack speak at SendHub's first Tech Talk. The speakers will be speaking on Go, SQL, and Android. First up is Caleb Doxey. Caleb is a stupendous software engineer at GNIP, where he works on front-end development, and he's also the author of the book, Introduction to Programming Go, and we'll be signing autographed copies after tonight's presentations.
Wait,
right?
Signing autographed copies, and they're already autographed.
Double the money. He'll be presenting on Secrets of Go. Please welcome Caleb.
Okay, so this title, Secrets of Go, might be a bit of a misnomer. This talk is not an introductory talk. A lot of talks about Go involve an introduction to the language. They treat it like you've never seen it before. This one is kind of a step above that. So I'm not going to talk about the language that much. So I'm going to talk a lot of different things really quickly. So if you get lost, we'll post these slides somewhere so you can see what I did. But hopefully you can keep up. I'm going to start with some sort of language tips, some shorthand in the language itself. But before we do, I wanted to mention something. This is an ancient Greek document written 2,000 years ago. And what I want you to notice about this document is that it's written all uppercase letters with no spaces between the words and with no punctuation. And Go is not a terse language. It's not like CoffeeScript or Lisp family of languages. It is kind of verbose. It's not as verbose as C++ or Java, but my point with this slide is this: shorter is not always better. CoffeeScript, yeah, you type less, but I would argue it's not very readable, just like this document is not very readable. And the introduction of spacing and punctuation to our language was a feature, right? Even though it's more verbose, it's easier to read. So this is a cautionary warning about some of these tips I'm going to show you. So shorthand, if you've seen it in Go, you've probably seen import statements, and you've probably seen, normally you write an import statement like this. So you can remove the imports, and you can collapse them with parentheses. It turns out you can do that with a lot of statements. So with types, if you say you have these 3 types, A, B, and C, they're structs, you can eliminate the type by doing this, which is sort of a, so you can do all these shorthand tricks. And you can also do it with variables, you can do it with constants. And so if you ever see yourself repeating yourself, you can do it this way. Another trick with variables is you can eliminate, so if you have A int and B int, you can say A comma B int, right? And this trick you'll see a lot in Go. You'll see it all over the place. So I'll show you some more places where you see that. So suppose you have a function and you define A equals 1 and B equals 2. You can collapse that like this. You can say A comma B equals 1 comma 2. Notice the equals here is the colon equals operator. That means you don't have to write var, so it's a shorthand. And this is pretty standard in Go. And the other thing you can do, which is really nice, it means you can do a swap. And so this is a swap without a temporary variable. You can say A comma B equals B comma A, which is handy. Okay. So here's another place where you see this comma working. Suppose I have a function add, takes 2 parameters, they're both integers and returns an integer. I can get rid of the one integer type there. I can say x comma y int, right? It's a lot shorter. You can do the same with types. So suppose I have a point, it has 3 coordinates, they're all integers. I can say type point struct x comma y comma z, they're all integers. Okay, so that's it for the language stuff, and now I'm going to show you how I can use some of that. Oh wait, this is the, I'll show you one more of these things. So this is a slice of points. It's like an array or a list from other languages. It turns out, well, first I want you to notice the way you create a point is you say point and then you give it the curly braces. And normally you'd say x is 1 and y is 1 and z is 1, but you can also just give them positionally, right? So I can get rid of the x colon. I don't have to do that. But the other thing you can do is get rid of the inner point. So it'll infer from the outer side. So these two are identical, right? And it turns out you can do this all the way down. So if I have a slice of points, I can do it this way, right? It's a lot shorter. You can do the same with maps. So suppose I have a map of string to point. I can do it this way, right? So I've gotten rid of the inner type, and you can also do the same trick with the multidimensional. So let's look at an example of that. And I'm going to talk about tools and some testing tools. testing is a big deal in Go. It should be a big deal in almost any language, but it's really nice that they've provided tools that make it really easy to do testing in Go. So let's look at an example. This is an add function, right? It just adds two numbers, really simple. And so if we wanted to test this, the way we would do that is this file is called math.go. You probably can't read that, it's really small. And all we have to do is create a math_test.go in the same folder, okay? And so once you do that, you have this package math, and we can create a test real quick. So, so we need to add the testing library, and then we can say test add. Oh, incidentally, I'm using Sublime Text here. The Go Sublime plugin is fantastic, and you just saw how I can add an import really easily. So definitely recommend that if you're using Go. And then if you can write the cases like this. So this is an anonymous type I'm creating. And it's going to have three fields, expected X and Y, and then we'll create our cases. So 1 plus 1, I wrote this backwards, is 2, right? And then we could say 10 is 3 plus 7. And then you could loop over it. So I can say the test case in the test cases, and then, oops. Then you would say the result is add tc.x and tc.y, okay? And then you compare that result to the expected. And we say if they're not equal, then we're going to fail the test, right? Because this is not valid, and you can say ACK or whatever you want in there. And actually, the typical way you do this, you say expected, percent %B, got, percent %B, or whatever. And then you could say, that way you can see what failed more easily. Okay, so that's our test. Does all that make sense? If you're totally lost, there'll be some time for questions at the end, and maybe I can answer some. But this, okay, I'll show you how you can do the test. So I'm in this folder. Let me get rid of some of this stuff. Okay, so we have two files in here, math and math test. And the way we test them is really simple. We type go test. Something's gone wrong. It didn't run the test. Oh, well, it said pass, but I don't think it actually, let's see. Yeah, okay, it did run the test. So notice how I changed 3 plus 7 obviously doesn't equal 11, our tests fail, and so this is a great way to write your code. In general, this is how you should write your code. You should start with a test and then implement the functionality, and then you can write all your cases, right? And now add is trivial, but if you were working on a real function, you could think of edge cases where you don't think it's going to work right, you put those cases in here, you loop over them. It's really simple. Now, obviously, if you're doing this a lot, one of the things you're going to want to do is you don't want to have to type go test every time, right? And so there's a lot of packages out there that can do test running for you. And so I'll show you one. So if you type go get github.com/Levi Cook, who wrote this package, and glitch is the name of the package. I've already installed it, so it installed it. And you type glitch, and then this will automatically run your test for you. So every time I make a change, save it, it reruns the test. Okay, that saves a lot of time over, if you're doing this a lot. There's another test runner which is more recent called go convey. So I'll show you that one. You just type go convey, and then in your browser, you go to, whoops, localhost 8080, which is the default port it uses. And now you have a test runner that's in the browser, right? And so now when I make a change, it reruns the test, and this is a really pretty UI for this, right? You can see what failed and a bunch of other stuff. Okay. One more thing about well, I should show you this too. They added in 1.2 a coverage tool. So coverage tells you how much of your code has been tested or is available in the automated tests here. And so you can say go test -cover, and I'm going to save this to a file so we can see it better. And this will, so I should fix the test here. Okay, so it says coverage 100% of statements, right? Well, we should make it not 100%. The way you do that, of course, you add some code that's not tested. So create a new subtract function, return x minus y, and then you can rerun this, and now it says 50%, right? Because half my code is not covered. So you can take that out file that I wrote here, and you can say go tool cover -html equal, and that file, cover.out. It should open in a browser. Yeah, okay. This is kind of hard to read, but you can see that it's highlighted my code, showing me which parts of the code are tested and which parts aren't. So, super handy. And in there's actually a whole lot of other features that go with this coverage stuff. Definitely look at the documentation, which is right here. You can see this covered. In typical Go fashion, when they decided to make a tool, they make it the best way possible. So it's really handy. Okay, so that's testing, and now, of course, another part of software development is documentation, and unfortunately, that's a part of software development that a lot of people don't do. And I think the reason why a lot of people don't do it is most languages, documentation becomes a chore to maintain. It's always stored in some other place. It's just really hard to get to, and so nobody does it. People just write code, and the way you maintain code is you go look at the source code. Go solves this problem in a really nice way, and so documentation is way easier in Go than it is in most languages. So I'll show you how we can do documentation. First, there's the go.doc command, which means you can run from the terminal and get documentation. So suppose I wanted to look at the HTTP library in Go. This is the documentation that you can see on the website. So it's in the terminal. And I can also look at an individual function by just putting it as a second argument. So, for example, servfile, I just wanted to look up what servfile does. It tells me exactly right here. Now, the cool thing about this is that this documentation comes from the source code. So, if I can do it on my own project right now. So, this is stored in presentation math. So, you can see that it's already documented my functions. And I can easily add comments. So I say, you know what add does as a comment, and you can see it shows up right here. So the cool thing about this is GoDoc also includes an HTTP server. So I can say this, and now I can browse to localhost 6060. And notice this looks just like the Golang website. That's because it basically is. It includes all of the documentation for all the packages installed on my computer. So if I go to package/presentation, which is the one I have here, /math, you can see this is the same documentation. And in fact, if I change it, it updates, whoops, what did I hit? It updates it automatically, right? So this is super handy. It means I don't have to do any work to make documentation for my code. It's just documented by adding comments. One other thing you can do is you can add examples. So I can say example add. And the idea here is that I want to provide code to show people how to use the stuff I wrote. And so I can write in here, I can say there is a, whoops, format library. This is what you use to print stuff. And I can say add 1 and 1. And the output, and you can do it this way, you say output : should be 2, right? I save that, and look, I now have an example available in the code. So I have added, it does this based on the name of the function, right? So it's called example add, and so therefore now there's an example to go with my code. So really easy to add documentation to your project. Here's another thing about documentation that's handy. They've done this in recent years. There's this godoc.org website. If you're a Go developer and you haven't seen this, you should definitely take a look at it. This has documentation for any publicly available Go project. And so you can go on here and find all kinds of stuff. So suppose we wanted to look at a PostgreSQL library. And the way this works is it's just the path on the end. So I know that this is at github.com/lib/pq. And this is the PostgreSQL library you use to connect to a database. It's completely documented. And the cool thing is that it's documented based on the source from GitHub. And so if I go to any GitHub repository that's a Go repository, it will automatically generate documentation. So I can go to, like, say, this MP3 library I have, and there it is. I didn't do anything to make that happen. I just went to that URL, and there we go. So it makes it so that if I make code for the general public, I can make documentation for it really easily. And the other nice thing about this site is it's also a great way to find packages. So suppose I want to have a SQLite library. Well, here's all the SQLite things, right? And so it's a handy way to find packages. And you can find almost anything in here. In fact, one of the difficulties with Go right now is that which one, right? And so it takes a little bit of research to know which library to use. Most of these are, they tend to be forks, right? Somebody has taken the library and forked it on their own. And, well, it shows up as a different name, but it's probably the same library. Okay, so that's our documentation. Another thing that's handy to do, of course, is debugging if you're actually working with code. There is no visual debugger for Go as far as I know, but you can use GDB. GDB is a command line debugger. And so I'll show you how to do that real quick. If you've never used GDB, I haven't used it much, but the way this would work is, well, first we have to generate a binary. Because when I run go test, like this, it just runs it. I need to make it so that it's something I can debug. And so I say go test-c, and I'm going to add some extra flags here to make it not optimize the code, because the compiler is smart and it sees, hey, look, you added, or hey, look, you're calling an add function that doesn't really do anything. I'm just going to inline the code and it goes away. So that's not super useful for what we're trying to do here. So if I take, and then this created a math.test here. This is a binary. It's basically they've taken the go test thing and thrown it into an executable. And so now I can debug it, right? I can say math.test, and now this fires up GDB, and it has a bunch of features. We'll just show one, math_test.go. I'm setting a breakpoint on line 18 here, this line. And then I say run. Oh, it's asking my password. And now it has run the code to this location, and you can look at the local variables and stuff, and you can see, hey, look, there's my test cases, and there's what TC is currently equal to, and you can use this to debug your code. Super handy. So another, of course, thing you can do is you can see the assembly itself, and I don't know how useful that is, but sometimes it's useful. And so that's how you do debugging. A little cumbersome, but it's not so bad. It just takes some getting used to. Okay, now I'll show you some profiling. Of course, in addition to debugging code, sometimes you need to find out why it's slow. And so profiling is a good way to do that. Definitely look at, if you want to know more about profiling, there's a lot of tools in Go that can make this, it's basically pprof. They have a version of it for Go, and you can do all kinds of stuff. It can generate charts and stuff. But I'm going to show you sort of the standard way to do profiling is just to make benchmarks. And so the way you make a benchmark is very easy. It's just like a test. I say func benchmark add, and this takes a b star testing.b instead of a t. It's a little weird, but and then you loop over this. So I say I less than b.n, and basically what the benchmark thing does is it gives you a really big number so that it can do enough cases to get something useful. And then I just say add 1 and 1, and that has created a benchmark. And now to run the benchmark, I say go test-bench, and you give it this regular expression, which is find the things that match, and just run this. Now it's benchmarking my code, and you can see that adding 2 numbers is really, really fast. So it took 0.55 nanoseconds per add. Now, of course, real code would take longer, and so this is useful because you can see what part of your code is going slow. So that's one way to do profiling. Like I said, if you want to see different ways, you can check out that blog article. Finally, I want to talk about integration. So Go can't do everything. There's a lot of things, and Go is specifically targeted towards low-level developers. At least that's one of the goals. And so those developers are also the kind of people who really want to be able to do almost anything. And so what I want to tell you, though, is that there are ways to do these things. They're a little cumbersome, but they're possible. It shouldn't scare you away from, oh, I don't want to use Go because it's garbage collected, or whatever. There are tricks you can use to get below Go, right? And so the first is CGO. CGO allows you to interact with C from Go, or vice versa. And so, of course, there's lots of libraries written in C, and so it'd be handy to be able to use those libraries without having to write them in Go. And to give you an example of that, here is SQLite 3 wrapper, and this is Go code that calls C code. And so you can see the way this works is you say import C. This is sort of a magic library, and before it you put all this sort of include whatever code, right? This is the C stuff. And you can also see how he's defined functions to make it easier to call. And basically the way this works is when you do this, you can call C functions via, by calling, let's see an example in here. Here we go. C.SQLite3. Like this is the C function name, this bit here. And you call it by saying C dot in the name of the function. And it does a lot of automatic conversion and makes sure like stack frames and stuff are right. And so it does a lot of work for you. It makes it really easy to call C functions. And so somebody has wrapped the entire SQLite library in here, which makes it so you didn't have to write SQLite in Go, right? So, which you wouldn't want to do. That's silly. And so this is a way to do that through Go. Now, of course, another trick would be instead of C, let's say we wanted to just call assembly. And to give you examples of, there's a lot of examples of why you might want to do that for math functions and stuff. And the Go compiler allows you to do that really easily by naming a file .s, and then inside there you put assembly instructions. Now, the kind of assembly it is Plan 9 assembly, which is underdocumented and kind of obscure, but it does actually work. And so here's a sort of more interesting example than just a math function. CRC32 is a hash algorithm. And what's interesting about CRC32 is in more recent processors, they have added an operation to the processor that can do a CRC32. And so it would make sense, instead of writing code to do this, I just call the assembly, right? And so you can do that, like you can see how they've done it this way. And sort of a lot of this is just boilerplate stack stuff. But you can see how you could write assembly if you were so inclined. And the way this works is you just put this file in here, and it automatically gets compiled into your Go code. So you can call this function. You can call this SSE42, whatever. So that's how you would do assembly. This is sort of advanced, pretty rare you'd ever do that. I wrote a blog article explaining in more detail if you wanted to try how to do it. Like I said, it's pretty underdocumented, but it's there, it's available. And finally, I want to talk about this syso thing. And I put a question mark because I've never really gotten this to work. But in theory, in addition to writing assembly, let's say you hate the Plan 9 assembler, like most people do, you can write GNU assembly. You can write regular assembly that you're used to. And you can do that via the syso stuff. So syso is basically a binary. And you can include it in your project. So I'll show you this. They've done this in, so this is part of the Go library, this runtime tool. This race detector. So this can detect races in your multi-threaded code and stuff. It's interesting, but apparently they have taken most of this code from the LLVM. And so what they did is they compiled all that code for the various platforms as syso files, and now they can call them from Go. And so they sort of bypassed the need to write the files in Go or in assembly or in C. They just say, well, I already wrote it, I'm just going to put it in here as a binary. You can see based on the size of the file, they've definitely done that, right? And this works as well. It does it based on the name. So this is Darwin is OS X, and AMD 64, of course, it is the platform. And so you can see how you can have very specific versions. Okay. So, sorry, that was a lot of information. So if you have any questions, please ask them. Yeah?
What is the best way to find, you mentioned there was a bunch of different types of packages, sometimes multiple different versions and flavors for a given, HTTP library or something like that. Like, what is the best way of finding the best one that most of the community uses?
Well, it kind of depends on the project. I don't really have a great answer to this question, but sometimes libraries are maintained by somebody who's pretty related to the project. So maybe there's a memcache library that's written by Brad Fitzgerald. Right? You would expect that, like, oh, I'll use that one because he wrote it. He's the guy who made memcache, like that kind of thing, right? But it's hard to know otherwise. Sometimes it's pretty obvious. You go in the source code and you're like, they implemented 3 functions. There's 100, right? Probably not that version, right? And so the other thing, often the one that's been forked the most is also a good indicator that it's heavily used. Because what it means is somebody forked it in order to fix a bug and just hasn't gotten back into it or something yet. So, yeah?
Does package managers work like Node.js?
No, it's basically unversioned. So when I say go get and then give it a patch name, so it's like github.com/badgerodon, which is a project. Like it went and got it. I'll show you with the dash v here. Right, so it's going to go download it, and then it installs it. And, it just runs like git clone, basically, and pulls down the source code. So if you wanted to do something more advanced than that, there's a couple different ways you can do it. One's called vendoring, and vendoring is where you take all of the libraries that you're using and put them into your source code. And there's some tools to do that, like GoDep and a bunch of others, which make it easier for you to do that. And then you can give them versions and things and specify, oh, I want this revision. So there's definitely tools out there that make it easier to do that. But the built-in tools are pretty dumb as far as approaching to versioning. Yeah?
If you have to compare Go as a backend language, as a web backend language, how would you compare it to Python or Ruby?
It's interesting because Go was kind of thought as like a rethought C, but I think it's actually a much better replacement for dynamic programming languages. Because if you look at this code, it doesn't look all that different from Python. And I would argue once you get used to it, it's just as easy to write. Like you can be just as productive. But it's way faster, and I think it's way more reliable because of the types. And so, I'm not the biggest Ruby fan, so I'm kind of biased here, but I think it's a great replacement for languages like that. And the other thing that's nice about Go is it definitely fits that service model. So maybe you don't want to rewrite Rails in Go, but you can write that piece of your API that's really slow, you can write that in Go and sort of use the two systems together. And I think a lot of companies have started doing that. They use it as, well, we do Rails for everything that's not slow or like doesn't matter, right? But for things that are really matter, then we switch to a different language, we'll use Go, right? It's great for that, so. Any other questions?
Maybe not. When you said the breakpoint, what I was having trouble with, if I have a package that has, multiple files, A, B, and C, if I want to set a breakpoint in file B, line 100, can I do that easily?
Yeah, that's a great question.
That's what I was trying to do. I
didn't think about that, but I suspect the way it would work is, if you've noticed, Go package names are just, they're just strings, and so you could have, I can say, I guess this wasn't, I didn't actually show an example of this, /mp3, like that's how I would include that library. And so it's probably something like this is what you would do, right? I don't know, I haven't tried it. I'm sure there's a way to do it, I just haven't done it. And there's a whole lot of things you can do in GDB. You can list the source code, and I haven't really messed with it. One of the examples they show in that blog article is they just do it by the function name, right? And so they say, instead of saying math_test, :1 or whatever, they say math.test, and then it will put it at the function, right? So there's definitely a way to do it, I haven't played around with it.
All right, so Android development in general is mostly just Java on mobile. So I'm going to try to talk about some sort of higher level things that don't overlap as much with other domains. The first of which is going to be Android layouts, which you'll spend a lot of time doing in Android. And the second of which is Android intents, which will save you a lot of time. So we get right into the layouts here. One of the harder things about developing for Android is that you have to cover a huge device space. Android runs on everything from wristwatches up to big screen TVs at this point. And you need a layout that's flexible enough to cover that whole range. And even if you're not going to deploy your app on all of those, you're going to need to hit a pretty big range in the middle. So if you're coming from an iOS perspective, one of the first things you'll notice about Android layouts is that there is no good graphical editor for them. And that's actually by design, because Google doesn't want you to do your layouts that way. They want you to learn how to do layouts with XML. So XML adds a fair amount of flexibility, and it forces you to add some logic regarding resizing your layouts right in there. But even that is not really going to cover all of your bases, which is why Android has suffixed resource folders. You can see some examples of those right up there. The way those work is basically you add these suffixes to the end of folders in your resources, and those tell the operating system which resources to use in different situations. So you can see at the bottom here, there are separate layouts for landscape versus portrait orientation, different screen sizes, you can do different pixel densities. You can throw one in, layout-DE would be a German layout in case you need a different layout to handle the long words. So the next issue that you'll get into is your layout scope. The first paragraph of Google's Android documentation tells you that you should tie your UI to your activities. And that's generally a really bad idea, actually. And I'll tell you why in a second. For those of you who aren't familiar with them, activities are the core component of an Android application.
Is that the events? Are you talking about events?
Events?
Never mind. I don't want to disrupt it. Sorry.
Anyway, so activities basically have the life cycle events for your application so that the operating system can start and stop it when it chooses. And they also give you the screen space to display any UI you want, which makes it seem like a good place to tie your UI into your logic. But the downside of that is that you can only have one activity on the screen at a time. So on a phone, that might be perfect if you're not doing a lot on that given activity. But if you ever want to move over to a tablet, your little phone layout is going to look very silly being that large. So that's why you want to use fragments. And fragments are pretty similar to activities. They have the same lifecycle methods, and they also give you a spot to draw in your UI. The difference is that you can embed fragments in other layouts. So the general practice that you want to follow is to actually have the layout with your activity just have a little frame where you can plug in fragments. And that way you can easily switch to having multiple fragments visible at the same time if you're on a bigger screen or fewer on a smaller screen. So despite the fact that I just told you to ignore Google and the first thing they tell you about, in general you should do what they tell you to. They have a whole lot of pre-built UI stuff available, and you should use that whenever you can. It is frequently tempting to build your own, especially if you only need a simpler, dumbed-down version of it, but that's probably a bad idea. The main advantages to using Google's pre-built UI is that it's going to be more flexible. It will cover use cases that you don't know you need yet. It's also going to be more compatible with other UI elements. I learned this the hard way recently. Attaching a menu to a homemade action bar is much more of a challenge than doing it with the default Android action bar. And most importantly, those elements are still being actively developed. So if a new UI trend comes along and now we have fancy pop-up menus from the bottom, they will build that into whatever components you were already using rather than you having to go and expand that yourself. So in addition to layouts, another important aspect of Android development is being a good neighbor. So there are some obvious elements of that. You are on a small device with limited resources, so you don't want to be a memory hog, you don't want to run down the battery. But in addition to that, you want to work with the other applications that are already on the device. And the way you do that is with intents. So the way intents work is that you can actually interface directly and anonymously with other applications available. So for instance, on the SendHub app, you can upload a file and send it as an attachment on a message. And we were able to implement this without touching the camera at all, without crawling through the file system, just by sending up an intent that says we want a file to attach. And everything else is handled by other applications. The way intents actually work, they're basically just requests for an action to happen. So something like making a phone call or sending a message or opening a file. And you just send this request up to the operating system, and the operating system will pull other applications and see if there's any application available that can handle that action. If you have an Android, you'll be familiar with this screen there. That's the pop-up you get if you have multiple applications that can handle an action. So once the user selects the application there, it will open that application for them. They'll use that UI to walk through and perform whatever actions they need. And when they're done, it'll close that, come back to the original app, and return any information that is required over there. So this is really great, obviously, because you don't have to build boilerplate stuff yourself. And it allows your users to use UI that they're already familiar with and not relearn how to do things. The other side of it is that you can register to receive these intents. So if there's something standard that your app does, and you want to let other apps do that, you can just put a line right in your manifest that says you can handle this intent, and your icon will pop up in that little dialog, and other applications can use you for that purpose. So that's obviously really good because you can bring in new users that way. But you do have to be careful because users coming in through your intent are not trying to hang out in your app for very long. They're trying to get something done and move back to what they were doing before. So if you are going to register for intents, you need to make sure you handle them and directly perform the action that's required and return the result right off the bat. So that is pretty much all that's required for you to make a sweet Android app. If you have the time to spend building a whole bunch of layouts and you have some knowledge of intents now and a little bit of Java, and you should be able to churn out some cool apps. Any questions?
Have you tried out Android Studio for the layout part?
For doing layouts?
Yeah.
I'm not sure I tried Android Studio. There are a few graphical layout editors, but for the most part, they're pretty bad. And the main reason being that if you're doing things graphically, you're placing things on some particularly sized screen. And unless you add the logic for how to change that, you either have the same layout huddled down in a corner, or it blows up and you have a bunch of empty space, or things are weirdly sized. And unless you add some of that logic, it's going to get messy pretty quickly on different devices.
I heard that one thing it could do is like switch to simulate different devices and see what it looks like.
Sure, sure. And you can use the Android emulator or something like that too, and look at it on a whole bunch of screens. But in general, then you're just building multiple layouts, basically, which is, I would imagine it actually uses that same functionality of the tagged folders to choose which one of those layouts to use in the end. Yeah.
I was thinking of the Ripple plugin to the Chrome browser and PhoneGap. Are you familiar with that emulator?
No, I haven't really used that. Yeah.
So you mentioned that the Android libraries are constantly actively being updated. I was wondering how good they are at maintaining backwards compatibility with pre-existing code.
They are actually surprisingly good. They have a whole set of support packages that they release with new releases that will often backport these new capabilities too. So like fragments, for instance, came out in, I think, 3.0, but if you use the support library, you can use them all the way back to 2.0. All right.
You talk about being a good neighbor. Does Android provide good methods for managing CPU usage and you know, asking for resources?
So basically, the way the Android operating system handles that is by ranking everything that's running on the phone at a given time. So the application in the foreground is going to have the top priority. Services that run in the background that you want continuously running are below that. And then applications that you put in the background will be a tier below that. And basically, if a higher priority application or service needs resources, it just starts killing stuff off the bottom, which is one of the reasons you need these lifecycle methods, because your application needs to be prepared to be killed at any time. Cool. Thanks for your time.
All right, let's try this again. So I'm Tom. I'm the CTO of Periscope, and
Go to open. Sorry.
Upper right, there's a present.
all right, so I'm Tom. I'm the CTO of Periscope. We are really good at data and not so good at presentations. So Periscope is a data tool for companies that analyzes millions and billions of rows of data really, really fast, and then turns them into dashboards and charts they can share with their teams. And the way we do it really fast is a lot of cool tech on the back end, like an in-memory database for computing sort of gnarly metrics. We do sampling over SQL tables. We do chunking of SQL queries. So if you have a really fat SQL query, we'll rewrite it into a bunch of little SQL queries, and then run those either in serial or in parallel, so you can get a bunch of data back sort of streaming. And all of this sort of is built on top of using a whole bunch of SQL and using it better and faster. And so hopefully in this talk, you will learn some things about SQL that you don't already know, and will make SQL better for everybody. So the first thing we'll do is we'll optimize a query. This query is a pretty normal looking query. It's just trying to make a list of dashboard names and how many unique users saw those dashboards. And so in this case, it's coming from the Periscope sort of backend database. We have a table called time on site log, which is a logs table. It has many millions of rows, and a database table, which is comparatively small. And so the problem with this query is that the join is happening before we do anything else. And the way you make code faster in any language is to do less work. In SQL, doing less work is looking at less data. And so instead of doing the join first, we'll do it later. And instead of doing the group by after the join, we'll do that earlier too. Because the group by is happening on dash, which is a computed column. So you coalesce name, dashboard ID as dash. And so we can't get rid of any data until the join is finished. So now we have this millions of rows joined with a bunch of more rows and a bunch of columns added. It's terrible. The database has to write stuff to disk. No good. So it takes 48 seconds to run this query. And so just by pushing the distinct action down one level into one of the tables, we reduce the amount of data and drop the query time in half. So in this case, we're still joining dashboards on sort of time on site logs, but instead of the original time on site logs, we're getting the dashboard ID and the count of distinct from that table. And so before the join happens, we're counting all the distinct things we care about, because we only really need the dashboards table for the name. Right? So if you don't need a table, don't include it in the join before doing the hard work. And so this is great, but we can still do even better, because a group aggregate function sucks. Those has to sort the data and then iterates over the data on disk. It's not in memory, so anything on disk in SQL is terrible. You want to keep all of your data in RAM as much as possible. And so the way to do that is, instead of using sort of the count distinct function, use a distinct wrapped in a count. And it sounds like the same thing, but really count distinct means you have one hash table per category. Right? Per dashboard ID, you have a hash table of session IDs. And the database doesn't know how many hash tables you're going to need to count the distincts, so it writes it to disk, because there's no room in RAM. But if you change it to, let's see, select distinct of just a pair of items, it can do all of that in one hash table, right? We're just getting a distinct list of pairs from this logs table. And then after we have that, then we will count it with the dashboard IDs and group it that way. And so this is super tiny. It stays in RAM. Time on site logs. The hash aggregate is a function that is a hash table join function instead of a group aggregate, which is an on-disk sort of sorted join function. And so those are way better. Oh, by the way, these pictures are from pgadmin. If you're using Postgres, pgadmin is amazing. You use explain, you get cool pictures, and it shows you what's going fast and what's not. And so you can make your queries way faster. And so just by pushing the distinct down lower and lower into the data, into the query, we operate on less data at each step. And we go from a 48-second query down to a 0.7-second query, which is like 50 times faster. And it's the same thing. Just less data, always less data on your queries. So that's how to optimize things. But now how about some cool like SQL features that you might not know about? So everybody knows how to get the biggest payment from your payments table. You just sort by amount and limit one. But what if you want the second biggest payment? That's kind of a pain to get the second biggest one on the table. So you use the command called offset, right? Limit one because we only want one row, but offset one kicks you down. So now you're looking at just the second row of the table. Or if you want to skip the first row but keep all the rest of the rows, so like 2 through n, you do offset one. So you're skipping the first guy, and now you're looking at the second biggest payment all the way down to the end. Yes?
So is this a pretty generic SQL syntax, or is this offset flag specific to certain SQL versions?
Offset is pretty standard.
Pretty standard.
Yeah. So you'll use it probably infrequently, but when you need it, it's like, yes, you can offset. So good. Love SQL. All right, so generate series is a Postgres specific thing, which is unfortunate for those of you not on Postgres, but it's really cool if you are on Postgres. So every once in a while you see folks making SQL tables like numbers 0 to 100 or 0 to a million, whatever, because you want to join numbers in with your SQL, because for some reason you need that, right? Your query is easier if you can join against a bunch of numbers. And so Postgres is like, why build temporary tables when there's a function for it? So generate series makes your numbers for you, and you can do regular old numbers. You can do really cool things like generate series of dates. You can skip every 2 days, and so now if you want a weekly thing, just like, oh, generate me all the weeks for this date range, for any date range. It's easy. So why do this? Well, let's go back to payments. So on payments, you have the amount and the date of the payment, and what you really want to see is how much money did I make each day. And if you had a bad day, you didn't make any money on that day, and you just said, group my payments by the date that they're created at and sum the amount, you'd be missing, in this case, December 2nd, because there's nothing to group by there. So that row is gone, and you're like, oh, my graph looks great. No, your graph is terrible. So you missed a whole day of money. But if you use generate series, you're guaranteed to get those dates in there, and you see that December 2nd was not an awesome day. Cool. Joins. So most folks, when they join on ID, right? Where users.id equals user tasks.userid, or where tasks.id equals my happy task pictures.id. That's cool. That's great for normal joins, but you can actually put anything you want in the join condition. So in this case, you can join on all the dates less than you in this table, right? So you generate the series of dates. We'll join in payments. And then for each date, we're going to have a join of all the payments that happened before that date and on that date. And so you sum it, and now you've done a cumulative sum in SQL, which is traditionally pretty hard to do because SQL does not like to do like running averages and cumulative sums. And so you can use the same trick with like a rolling 7-day average, right? You get a list of dates, and you join in my date and all the my date or between this date and date minus 6, right? And now you've got 6 or 7 dates per one, sum them up or average them or whatever. You've got a rolling 7-day average, which is pretty sweet. You don't have to export it into a separate tool. SQL does not do transpose. Sometimes you get rows, sometimes you get columns, and you really can't do the other way around. It kind of sucks. But in this case, if you want to format your data the way you want, there's 2 ways to do it, right? There's easy mode, which is select 1 as A, 3 as B, 5 as C. Just make a bunch of columns. It's pretty standard. If you use the union syntax, you can make a bunch of rows. And so, a more interesting query, if you want to say like, oh, look at my users, my payments, my dashboards in a row, because that's what you want to output, you can do it this way. Or, you can use the slightly longer SQL syntax, but now you have your stuff in a table. And that just makes it super easy to do joins against these things, either joining multiple tables together, or exporting it to a program that wants data in rows instead of columns. Okay, there's a couple of things going on here. This one's pretty cool. So case statement is like an if-else clause for SQL. If you don't know about it, you're like, mind's blown, so good. So now you can do if and like filter out like if the name matches this, or a name includes this, or the number is above this or below this. And of course, the case statement can have like case this, case that, case the other thing. So now you have a whole bunch of different ways to segment your data. And so in this case, we're going to say when the view count is less than 4, we give a 0, otherwise a 1, because we're wrapping the case statement in a sum clause, right? Because you can sum zeros and ones. It's like a conditional count at that point, right? Like count if in Excel, this is count if in SQL. And so we can convert a table of like date user ID view counts to date percents, because what we really want to do is divide the view counts that match a certain criteria, right? Activated users, they've had at least 4 views or something. Pretty cool, right? Count if in SQL. All right, last one, really cool. Window functions are really powerful. They're mostly in Postgres, but other languages have them too. You have a cool table like this. You've got a couple different dates and platforms for those dates and counts of things. And what you really want is the percent of Androids for that date. Right? You have Android, and iOS and something else on the first and then second. And you could do multiple subqueries and join them together on the dates, and because what you really want to do is divide Android by the sum of Android plus iOS. And that's really hard to do on just SQL and subqueries and joins. But a window function gives you access to data that's nearby, right? So in this case, we're saying, give us access to the data that is grouped by date. And so the sum of the count function on the line 3 there is actually only looking at 2 rows at a time in this example, instead of the whole table at once. And you can do other cool things in window functions, like look at all the rows between the first row and now ordered by, and me ordered by create at, or ordered by the date. And so this is a really powerful once you get the head around it, but it's kind of tricky. So that is the secrets of SQL or something. Yes? And how about some questions?
Are most of these Postgres?
No, just generate series is Postgres only.
Okay. Because I don't remember, like MySQL doesn't have the windows and
They have something very similar to that, yeah.
So at the very beginning of the talk, you mentioned a whole bunch of information about, well, when you do this, it's stored in memory, or when you do this, it's stored on disk. Where's the best place to go for that type of information to understand and analyze your queries versus, otherwise, because you can do the explain and analyze in SQL, but like, where do you find how it's actually being stored on in memory or disk?
So if your query takes longer than a second, probably on disk. But really, the explain is really good friend. If you learn what each of the different types of things mean in explain, you'll be like, okay, this is sorting and then grouping, and it's not in RAM, because if it wasn't RAM, it could use a hash join instead, things like that.
I know it's not a Periscope talk. You're talking about you're processing billions of events and all that stuff. What's the backend like?
So the backend for Periscope is a whole hodgepodge of things, because when it comes to processing data really fast, there's no one perfect thing, I guess, except for Periscope. But so we have an in-memory Java database that we wrote, and we use that and a bunch of bit set math to slice and dice data by dimensions and to do hard queries like retention. Because retention in SQL is awful. Finding out this person was activated and if they came back and how many times, nope. So we do all that in Java in a fancy store. And then a lot of the rest of the work is in sort of a big pile of Ruby that generates SQL to send to various databases that either split the data apart or put data back together and figure out how to count it in different ways that are interesting for the metrics. All good? All right, well, thank you very much.
Thank you, Tom, and thank you everyone for coming out. Please be on the lookout for our next tech talk. We had a lot of fun putting this on, and we hope everyone enjoyed it as well. Everyone have a good night.
Beer and pizza.
There's beer and pizza and wine still left, plenty of it. Please enjoy and drive safe.